This lecture is on congruent figures. So congruent basically means same shape and same size. More specifically, what we're talking about is that corresponding angles would be congruent and corresponding sides would be congruent. So corresponding angles would have the same measure, corresponding sides would have the same length. This is an example of two congruent pentagons. Here we have pentagon ABCDE and pentagon VWXYZ. And this is a congruence statement down here which represents that information. And the congruence statement is very useful in that the order of the letters indicates the correspondence. So what you need to do is make sure that you don't skip letters. You can't say pentagon A, C, E, D, B. That's a different pentagon actually. You have to go in order around. And also, besides the order, you have to match up the two pentagons. And so looking at the order, we can say that segment BC, and segment BC, we're talking about second and third letters. Well, second and third over here is WX, so segment BC must be congruent to segment WX. Or we could also say, for instance, segment EA, so fifth and first, so this segment here must be congruent to this segment here. And so that's also fifth and first ZV. So that's corresponding sides. Now, of course, we can do corresponding angles. We can say angle A, so first letter, congruent to angle V, first letter. Or angle X, third letter, congruent to angle C, third letter. Or we can rewrite the congruence statement by changing the letters around a little bit. So we have DCBAE, YXWVZ. So same information written slightly differently. Here's an example of using a congruence statement and some algebra. So we have two triangles, triangle EFG and triangle HIJ, and they're congruent. And we've labeled the sides to indicate that information, not the angles, but just the sides for now. We know that EF is 9x plus 2, HI is 4x plus 17, and JI is 2x plus 3. We want to find x and JI. So we know that these two sides are the same length, so we can set them equal to each other. So the corresponding sides will be congruent. So therefore, 9x plus 2 is 4x plus 17. Subtract 2 from both sides. We get down to here, subtract 4x from both sides, divide by 5, so x is 3. We can take the 3 and plug it in for JI. So we have 2 times 3 plus 3. It ends up being JI is 9. So what we have here is all these corresponding sides being congruent leads to congruent figures. Now, focusing just on triangles, as we're actually going to be doing more of the rest of the chapter, we have this idea called CPCTC. CPCTC, it means corresponding parts of congruent triangles are congruent. And we're going to use this in two directions, logically speaking. For now, what we're going to say is, in order to get two triangles congruent, we need all 6 of their parts to match up. So the 3 angles and the 3 sides. And you can think of it as side angle, side angle, side angle. So that's why it's SA, 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 with side angle, side angle, side angle. But as we know, if you have 2 angles in a triangle, you know the third because of the triangle angle sum theorem, 180 degrees in a triangle. So therefore, you really don't need to have that third angle because just having 2 angles determines the third. So now we're down to just side angle, side angle, side, as I've labeled in these 2 triangles. So that would be enough to show that 2 triangles are congruent. And we'll see in days to come that actually you can reduce this even down to 3 parts, side, 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 angle, side, angle, and angle, angle, side. And these are 2 notable examples that don't work, angle, 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 and side, side, angle. Here are a few more examples of using congruency to get information. So in this problem number 2, we want to get angle 3. These angles match up, so this must be a right angle, 90 degrees. This is 135, so therefore this is 135. Over in this example, angle Y is a right angle, so angle D is a right angle. So excuse me, angle E would be a right angle. And then angle X and angle D go together, so this is a right angle. 140 indicates that this would be 140 as well. And then in order to get angle 7, we do 360 degrees because it's a quadrilateral, minus 90, minus 90, minus 140, leaving us with 40 degrees for angle F. Over here, we have a congruent statement. Triangle CAT is congruent to JSD. Now, the triangles are drawn over here, but the congruent statement is really enough, and usually it's a good idea to have a drawing, but here you don't really need it for very much. 3 pairs of congruent sides, you could say, for instance, angle CA, or excuse me, side CA, segment CA is congruent to segment JS, because first 2 letters, or segment TC congruent to segment DJ, third and first, third and first. For angles, angle C is congruent to angle J, first letter, and so on. And down here we have the beginnings of proof. We're going to be doing a lot of proofs in this chapter, so this is the start of it. So angle Q is congruent to angle Q. Well, that's already labeled, so that's given information. Angle LNM is congruent to angle PNQ, so let's draw those in. And that's true because those are vertical angles. And then we have angle M congruent to angle P, and well, that's true because of the triangle angle sum theorem. Once you know that the one arc 2 arc and the one arc 2 arc are the same, then these ones must be the same as well. Then we have that all these sides are the same. Well, that's all labeled, so that's given. So finally, we've got all 6 parts up here congruent to all 6 parts down here. So that's congruent triangles because corresponding parts of congruent triangles are congruent. All the corresponding parts are congruent, so therefore the triangles will be congruent as well.